All right, here I have a table. Here's a table of values, and I want to figure out, is it linear, is it quadratic, or is it exponential? So the first thing I'm going to do is I'm just going to kind of scan. My x's are going up by the same one. Okay, so now I want to check to see what's going on with my y value. So we're kind of trained to figure out the differences. This is going up a half. This is going up 1. This is going up 2. This is going up 4. Okay. So now that's the first difference. The first difference is all different. So now so we know it's not linear. All right. It's not linear because the first difference is different. So now let's check out the second difference. The second difference. This goes up a half again. Oh, my paper's being funky. This is going up 1. This is going up 2. The second difference is different. That means it's not quadratic. So I could go to the third and the fourth and whatnot, but we're not going to do that. If it's not linear and not quadratic, that doesn't automatically mean it's going to be exponential. But what we can do now is look at it a little bit differently. All right. Now, instead of looking at the difference, the common difference, let's see if there's a common ratio. Meaning, if I were to take 8 and divide it by 4, what do I get? Very good, it's 2. And now if I take 4 and divide it by 2, I get 2. And if I take 2 and divide it by 1, I get 1. Each time if I divide a y by the previous y, I get the, oh, that should be hit 2, silly Stanwood. This is the common ratio. And if we recall when we talked about exponential functions, it had a common ratio. It's always doubling. So that's how you can tell by a table if it's an exponential function.